Hey everybody, thank you for taking the time out of your busy schedules to join Riley and I for this month, February of 2021's TBC Power Hour. Today we'll be covering all things tunnel surveying and all the improved solutions that we have here at Trimble to kind of have one tunnel solution, covering everything from the Trimble SX12 to the access and TBC functionality. With that, I'll go ahead and jump to the next slide. I'm Jeff Ryan. I'm the TBC product manager based in Westminster, Colorado, and I'll be joined by my tunneling guru and colleague, Riley Smith.
Yeah, hey everyone. You've seen me a few times in the past TBC Power Hours talking about my favorite subject being all things tunneling. So back at it again today, and same with Jeff. I'm based in Westminster, Colorado, and put my email up there in case anyone wants to reach out afterwards to talk more about tunneling.
Likewise, excited to have Riley today. He's a very nice and tunneling expertise. So we'll tap into that today in this agenda and talk about some of the tunneling surveying overview. Then we'll jump into the tunneling solutions here at Trimble and then go through some tunneling examples and demonstrations and take some time for walking through some of the resources that we have, as well as some Q&A for you guys, which leads to a nice segue. If you guys have any questions, feel free to put them in the questions box and we'll try to get those answered throughout the webinar. If we don't get to them now, we'll get to them a little later through email.
Okay. There was a comment that came in that someone was not able to hear anything. Can maybe a few others that are on the call just put in the chat if you're able to hear and see the presentation, okay? And hear us. Awesome. Thank you, everyone. Appreciate that. All right, so we'll keep going and get on with the presentation here. As Jeff said, feel free to put any questions you have in the chat. We'll answer them as we go and have some time at the end as well. So I wanted to start this off with kind of the message of why Trimble tunneling and what our tunneling area is all about here at Trimble. And it's all really focusing highly on tunnel surveying, whether it's from the start of the project in the construction or at the end when a tunnel is built and we're looking more at inspection and maintenance operations. And it's all about providing system solutions that are reliable, first and foremost. Tunnels, tough environments, you need to have reliable instruments, and also productivity. The word there, fast, to me means productivity in those projects. Now, from that perspective, I look at the surveying piece of a tunnel as a life cycle, as there's a variety of areas throughout the tunnel life where you need surveying, where you need geospatial data, whether it's the start of the project, starting in the upper left-hand side where you're talking about defining the project, you're collecting the initial data for the site, the topographic surveys, you're doing the geodetic control, setting it up for the tunnel that will be built. And then you move into the construction process, depending on the type of tunnel, whether it's a drill and blast tunnel, whether it's a TBM, and a variety of other methods for building the tunnel. There's an element of construction surveying, and this is really the core of what we'll talk about today, is all of the construction survey applications. And also, of course, looking at how the survey technology helps guide machines, whether it's TBMs, road headers, drill and blast machines, shotcrete spraying, whatever it might be, how technology like total stations and scanning is being applied into that. And then the key component is also monitoring both above and below the tunnel. So assessing the convergence of the tunnel after it's been built and understanding how it's converging in itself, but also above the tunnel and understanding structures and important infrastructure around the construction project and seeing how that's moving relative to any work that's going on underneath. Of course, reporting deliverables is really what we care about at the end. What is the final deliverable after we've collected that data? Is it a CAD model? Is it an as-built report? And providing tools that can do that. And then at the end of the tunnel life cycle, talking more about the inspection and maintenance. So we have this asset, this tunnel, collecting geospatial data about it, whether it's in structural integrity using mobile mapping and scanning systems to collect really high detailed data about that, and being able to catalog those assets in a more efficient way. So that's the tunnel survey lifecycle. And you can see more about this on our website at tunneling.trimble.com. So Before getting into more of the technical aspect and the Trimble solutions, I want to talk about what are the current challenges. Now, I know these don't cover all of the challenges that happen on a tunnel project. There's a million and one things that can happen, but some of the big things that they're constantly challenges for tunnel surveyors. Starting on the left-hand side, we talk about project schedule and downtime. So tunnel construction projects are often 24/7 efforts. They're continuous construction operations. Any downtime in that construction can lead to significant costs, and delays, and the project. So it's really important for surveyors to have confidence in the equipment and the technology that they're using to ensure that they can provide data to the construction teams, whether it's to the machines, to the geologist, whoever it might be, to ensure that that process can continue on uninterrupted. And a part of that is all about reliability and durability of instruments, and knowing that the total stations, the scanners, whatever it is you might be using, will handle those tough conditions and work throughout the tunnel life cycle. Now, moving on, we're talking about data delivery times. So this is all about getting data, whether it's the as-builting, whether it's the control data, getting that as fast as possible and getting the deliverable to the client, to the stakeholder in a meaningful way. And so through this, trying to automate some of those conventional survey tasks that we do already in tunneling, but trying to remove the need for as much input from the operator and speeding up the time to get that data, as well as removing any manual errors that may have happened in the past. Now, that third category is about workflows. This is more about how does that data cycle throughout the entire project? Is it moving between 10 different software packages? Is it changing hands with 10 different stakeholders? And trying to connect all of that so it's a seamless transfer from the surveyor to customer or stakeholder X who needs that data. So now I'm going to talk about how we're addressing these challenges from a Trimble perspective. So when we look at the tunnel survey workflow, I break it into first the starting piece, which is in the office. How do we prep all the information we need to go out to the field and do the survey? And then talking about bringing that data back to the office. So starting about that piece, which I look at more as the data prep, the preparation step on getting things ready to go do the survey. So this is where Trimble Business Center comes into play. We have the Trimble Business Center tunneling module, which allows you to take a design, whether it comes from a blueprint, a 2D PDF, or it comes from a CAD file, and getting that into a format where you can visualize the design in TBC, and you can do any additional data prep, whether it's putting set out points if you're doing drill and blast, or you're doing you got to set rock anchors or whatever it might be, but also the platform for integrating all of the survey data. So not only do you have your tunnel information, your tunnel survey data, but you also have all that geodetic data, whether it's you're doing a level loops through the tunnel, you're doing traversing, all of that data in one ecosystem. Now, when you get to the field, you can leverage Trimble Sync Manager for the connectivity piece, so getting data out to the field. And once it's out in the field, this is where we leverage the optical solutions like the Trimble SX12, which I'll talk a little bit more about here in a second, and also the software, Trimble Access Tunnels, which is really the key piece when it comes to doing the workflows in the field. So that same design information, same data in TBC transfer seamlessly out to Trimble Access. So when I'm in the field on the data collector, I'm seeing the exact same design, same alignment, same shapes, all of that information in Trimble Access. And I have access to me while in the field tools to do any design review or editing as needed. If there's a change and I need to make it that second in the field so I can keep up with the construction crew, I can do it. I also have all the tools I need to do any of the set out and positioning. So whether I'm setting out blast holes, whether I'm setting out rock anchors, whatever it might be, you can do that in Trimble Access. There's also some basic machine positioning functions. So if I need to direct a road header, I need to give them kind of the extents with the laser pointer, I can use the alignment and the design information to position that with Trimble Access. One of the automated functions that I really like in Trimble Access Tunnels is the automated as-builting, where we take the tunnel design and automatically collect the as-built profiles based on the values that the user inputs. And then of course, in-field reporting is huge. So not only is it collecting data, but it's also having that real-time feedback while in the field. Has the data I've collected, if we built the tunnel in the right spot, is the overbreak significant? Is there underbreak, so we need to excavate more? That kind of feedback while I'm in the field. And once you've collected all that data, for more of the comprehensive analysis, more of the reporting and deliverable piece, bringing it back through TBC. Same thing, all of that data comes seamlessly into TBC, whether it's survey data from the total station, whether it's level data or scan data from something like the SX12, all sits in that one environment. And we can generate a variety of different reports like as-builts, customizable reports, whether it's an as-built report, inspection report, whatever it might be. You can change up the layout, you can add your company logo, whatever you want to it, and still get all of that data that you need from it. There's also the tools for drafting. So if I need to do any plan, profile, cross-section sheets, I can do that. And I can export them PDF, or I can go out to CAD. And then the final piece, which I think is really powerful, especially used with the SX12, is the scanning tools. So the automated scan cleanup, removing all the parasites and the noise from the scan data so I can get to the deliverable faster. And of course, the automatic georeferencing using the SX12 or SX10, where that survey workflow, we still take all of the backsite, the resection information, and it's coordinated with the scan. So if I have to update my control information, that scan data moves with my control. So really building that confidence on all of the data in one environment. So that's looking at the workflow from a high level. Now I want to get into each piece of that in a little more detail. So starting with the Trimble SX12, which if you're not familiar, this is a new release, came out not too long ago, about 2 weeks ago. And really the core message about this instrument is the everyday use of it. And today I'm going to talk a lot about tunneling and the underground operations, but I think this instrument is great because it can also be applied across a variety of survey applications, everything from just general topographic surveys, whether you do roading construction, infrastructure, whatever it might be, really flexible in how you can use that instrument. Where I think it's really important for tunneling, and I'm sure a lot of you think the same thing, is the green laser pointer that we've introduced in the SX12. One being it's very powerful. So 3mm spot size at 50 meters. So really easy to see, especially for those operations where you're trying to stake out discrete points in the tunnel, trying to mark out blast holes, whatever it might be. Really easy to see that in those challenging environments, variety of settings where you can change it, whether you want it flashing, you want it high powered, low powered, all of that kind of thing. It is the smallest spot size in the industry, fantastic instrument for tunneling. And the best part about it is it's class 1M, so it's an eye-safe laser, so no concerns there. Another update about the SX12 is its updated camera system, what we call the Trimble Vision technology. And so a kind of a comparison of the SX10 versus the SX12, and you see a kind of drastic improvements in all the types of the cameras in the SX12, whether it's the overview, primary, or telecamera. Great improvements in resolution, so getting better imagery and video from that. Now getting more into the software side of things, the Trimble Access piece. So really 4 categories, and I talked a bit already about these, where we can do all of the geometry, whether it's the alignments, the templates, the shape, information in Trimble Access. We can get that from TBC. We can actually key it in Trimble Access too if needed, and we can define any of those key setout positions as well. Now from there, once you have all that design, you do the automated surveying setout. If you're doing setout points, if I'm setting out blast holes, I can automate it. Say if I need to mark those points, I can set a time interval where it will stake out and automatically move to the next point and giving me enough time to spray paint or mark the tunnel surface. As well as automated as-builting profiles, which I talked a lot about already, and I think that's a key feature, especially for productivity in tunnels. And the survey and the machine positioning. So along with just general positioning in the tunnel, whether I just need to know where I am, if I'm marking stationing along the tunnel, or if I'm collecting certain points, if I'm setting out patterns, or I'm setting out different kinds of features at certain stationing and offset along the tunnel, I can use that in Trimble Axis. I can also do the basic machine excavation positioning or drill positioning, and that in field reporting and review. So we can generate very quick and simple as-built data reports in the field. And of course, combined with all that, we have the scan data from the SX10 or SX12, which you can have in context for all of the survey data and the design that you've collected. On the TBC side, once again, 4 categories. We're going to keep it simple in terms of the how we describe it. It's one is once again about the design. So the tools in TBC, I would say we have the same in Trimble Axis, but more and better. You can do a lot with alignments, how you create them, whether it's from an existing CAD file or you're keying it in manually. And same with the shapes and the templates, but we also can visualize the design in 3D, so you can create nice meshes that show the design as well as the as-built data. Once you've collected that data, there's a variety of tools to clean it, process it, and generate visuals from it, whether it's a 3D mesh, whether it's a report, or an as-built analysis. And once again, all of that cleaning all of the noise from the scan data and making sure that what you're getting is the data that you want. Of course, reports, a variety of reports. Jeff and I are going to demo some of those to you today, especially as-built reports, which are very important in tunneling, but as well as other types of reports like the inspection workflow especially for NATM tunnels, drill and blast tunnels, where we've got this iterative process of tunnel construction. And I think a really key point here for really any system that you have doing tunnel surveys, you need that confidence in the data and design exchange between the office and the field. You want to know what you collected in the field is getting transferred, all of that raw data is getting transferred to the office, and vice versa. So with saying that, what I'm going to set up here is the demonstrations that Jeff and I are going to go into, focusing on Trimble Business Center, and we're going to try to highlight some of the new tools in the latest version of TBC, which is version 5.4, which came out in December. And to do that, we're going to take two examples from what I would say are 2 of the most common tunnel construction methods in the world today. So the left being TBM, or tunnel boring machine, where we're essentially boring through the earth in a linear path. And then the other being NATM, which is known by a variety of terms, but essentially the iterative process of doing drill, blast, and excavation with a variety of layers in that construction process. So we're going to show how you can use survey and scan data, especially with the SX12, for both of these applications. So to start, I'm going to kick this over to Jeff. Maybe, Jeff, do you want to talk to this before I send you the presenting rights?
Yeah, thanks, Riley. I can talk to this real quick. So as Riley mentioned, I'll jump into the tunnel boring machine survey. And for this data set, I'll be covering a really interesting project out of Paris, which is the Grand Paris Express. I think they're adding in a 200 kilometers of underground tunnel railway, which is a really fascinating project. And so we'll be able to take you in real life into this data set here and show off some as-built reporting for the tunnel ring position using the scan data. As you can see, they kind of look like puzzle pieces on the wall or the envelope there. And I'll walk you through how to set some points in those positions and then generate some reports. We have a nice little quote from Olivier Gauche from the Eiffage, who's a survey engineer there. It's just kind of complimenting how super easy and simple this whole process is. And so, yeah, today I'll be walking you through this SX12 data set. We'll do some automatically cleaning of the scans with the classification. I'll show you how to do some assigning tunnel points and then creating that report. And with that being said, Riley, you can just flip it over to me.
All right, I can see TBC.
Cool. Let me get my GoToWebinar out of the way here. All right, so now as you guys can see my screen, I'm in plan view right now with the tunnel data. Just so you can see real quick, I'll flip to 3D view. This looks pretty similar to the image that I had in the slide deck. And going back to plan view, what I'll do here is first off showcase how to classify this tunnel region, just so we can get, if I look at the inner part of this tunnel, we're gonna have people and work equipment, this walkway and the tunnel ducts, what have you, that are in the way and kind of areas that are noisy, and we want to eliminate those from the point cloud. So for the first thing I want to do is classify that to get rid of it. And what I've done is I've created a region, cutting off all the excess data, the tunnel data that didn't get shot in with that SX12 scan, just to help the algorithm out in finding all of this. Ideally, you would have an SX12 go through the entire tunnel, so you have a swath of survey data or point cloud data that really helps guide that algorithm. So for right now, I'll just focus in on this area, and I'll come in here to the Classify Regions tab or command. And when I launch that, all I have to do is go ahead and select the region that I want, which will be this one. And you can see I've selected one region. I do, however, want to turn off this checkbox to create a separate region for the bottom of the tunnel. And I'll show you here in 3D view what that means. This would be really useful if you have a tunnel with a flat ground at the very bottom instead of all a cylindrical object, so that you can classify the ground at the bottom. So for this, I'll just turn it off and I'll go ahead and extract.
Cool. So just to note, I'll make a note
And
about that option you were talking about, Jeff, with the selecting the tunnel bottom versus just the shape. So that's really an important option if you're doing NATM tunnels or drill and blast, where you need to know the inverts of where the tunnel shape meets the floor, and so you can extract kind of the floor point cloud versus the what I would call the shape of that.
Thanks, Riley. And you can see after this is done, it turns blue. And you can, this really got rid of all that excess noise. And now I'm ready to go into assigning tunnel points. So that being said, I think I have some overlap here from my practice runs. But yeah, you can see how much this got rid of here just by clicking this first initial region off.
So it got rid of all the ducts and like the piping and stuff on the side. Yeah, cool.
All right. All right, well, next thing I'll do is go ahead and close out of this command, and I'll go ahead and do the assign tunnel points command. And for that, I'm going to go hop into plan view. So I get a top-down approach and a nice look at how these rings are situated, if you can see that pretty clear. And I'll go ahead and do the assign tunnel points command on the far right. And here I've got the gallery tunnel design selected, which is the correct one. The next thing I want to do is come down here to the selection method area, and instead of doing from the job file, what I want to do is do from the point cloud. And I want to make sure that I grab the point cloud that is classified, which I've already done. And you can see here that I'm ready to begin pick my begin station. And so what I'll do is I'll go ahead and click in that box, and I will follow along this alignment and begin to click my first spot. If you can't see where my crosshairs are, a really nice tool that's added in with this selection is that I can kind of pull this cursor out and it'll follow along the alignment along the way. So what I'll do here is I'll grab this first ring closest to the instrument, and then I'll define my second one, probably, let's say 3 or 4 rings up, just for an example. And what I'll do next is I'll do a station interval of 2 meters. just because these are kind of the begin and end station. You can see these are about 8 meters away. So if I do 2 meters here, I should be able to get points around every ring or in that general area. And then the next thing I'll do is leave these boxes unchecked, and I'll go to the tunnel shape and I'll select this bouclier. Excuse my French accent or lack thereof. And then I'll go down to the point cloud region right here. And what I'll do is select the classified region once more. Once that's selected, it'll say it's selected 1. And then I'll keep the search distance the same. And then going down to changing the sample interval, I'll change this one to 2 meters as well. And what that'll do is we'll get a point along the ring every 2 meters at these defined stations. And then the next thing I want to do is walk through the automatic point numbering. So you can see here, this format is going to say the station number. So the first point will say 2061.82, the beginning station, and then underscore, I believe, 0. And then it'll go clockwise around the tunnel shape here to, my tunnel station number to underscore 1, 2, 3, 4, and so on. And I'll show you that here in a little bit. You can have the ability to assign the points layer and the feature code, but for now I'll leave that blank and I'll just go ahead and hit add. And what this will do is populate the points at each interval. And you can see that it's creating the points from the point cloud down here at the bottom. And it's loading now.
Yeah, so while that's going, let's maybe answer a question or two. So a good one came in from Steve about the classification tool that you showed previously. Does it work on non-cylindrical tunnels? So a good example, which I'll show here in a minute, is like a NATM style tunnel, the horseshoe shape where you have a flat bottom and maybe an arc top. And the answer is yes, Steve, it works on those types of tunnels. The only thing I would say to be aware of when using that classification, as Jeff pointed out, is if you have kind of areas where the scan data trails off and you don't have good density, which is what you get kind of at the extents of the scan, is just doing a simple rectangular select or a polygon select to select the area where you do have full coverage of the tunnel with the scan, and then running the command. It just provides better results because then it's not trying to remove data where you have poor scan resolution.
Yep. Awesome. Well, as you can see, this has generated all the points, and you can see that at every station, I've got 14 points, and they fell pretty nicely there. They're over almost at every ring. And what I can do here is go ahead and apply. After it says 56 points were assigned, and I'll go ahead and close out of this. And I'll go to 3D view so you can see how these fell real quick. You can see they fall right along each ring, which is a nice generation of points. Okay, so the next thing I'll do is go to create the tunnel ASCII report. And what I'll do here is go to this tunnel ASCII here and drop it down to create a profile with Microsoft Word with report with areas. And what this will be nice to do with the areas sheet here is to be able to utilize Trimble Access and the style sheets. And so once I come into this menu, I'm going to expand this panel a little bit so you can see the very options at the very bottom here. And I think everything looks pretty good. I've got my tunnel design, my tunnel shape selected here, all my stations with my counts of points. And so the only thing I'm going to change here at the bottom is flip this option to compute as-built alignment offsets and circular profiles to yes. So I want to check that in the report. And I'll go ahead and hit apply. And here you can see the report. It's a nice generated report with the Trimble logo on it. You've got your tunnel profiles, name. You can add in all of these specifics here as you wish. And if I could scroll down, I do want to show another report here that displays this a little better. In this tunnel profile section, there's some really valuable information here for tunnel surveyors. We can go into this calculated as-built alignment point here, which is right in the middle. And essentially what this is going to show is these values are showing the difference between the as-built and the design to show where the boring of the tunnel has happened and compares to where it to the design. And you can see all these horizontal and vertical offsets, the deltas from the center point, and then the calc radius as well. Riley, do you have anything else that maybe tunnel surveyors?
Yeah, I think when this document got saved, it lost some formatting in the imagery because it will also show those values for the over and under break in that deviation. So essentially with TBM tunnels, you really care about where did the tunnel actually get bored. It's never going to be right on the exact design alignment. It's just not possible. It's whether it's a few millimeters or a few centimeters, that tunnel is always going to be built kind of slightly offset of the design. And so it's important to know where that center point is and comparing it to the design. So for future construction activities, whether it's you're setting out the rail track or something else, that's all referenced to the design or the as-built position of the tunnel and not the design. So essentially it's good data to have, and we can update the as-built, will say, for future construction process. Like I said, the tracks or whatever it might be. So, and as Jeff, as you mentioned, with those ASCII reports, if you go back to TBC really quick, those are all based on what we call style sheets. So those reports can actually be generated while in the field in Trimble Access as well. So if you need kind of that real-time feedback while you're in the field, you can run any of those reports using the style sheet in Trimble Access.
Awesome.
Cool stuff. All right. So with that, I think I will jump it over to mine. Give me 1 second. Jeff, just give me a thumbs up if you can see this screen okay.
Yep, you're good.
Awesome. All right, so with that, we're gonna go to the next example, which is all about drill and blast or SEM kind of type tunnels where you're going through an iterative construction process. One thing I'd like to say here is really the power of using the scan data from the SX12 with TBC for those kind of iterative construction reports, whether it's checking the excavation versus design, doing the shot creep versus excavation, or checking the final lining placement, any of that, and using those tools. So we'll jump into some of the new tools that we've developed in the latest version of TBC that are really useful for this process. And we're going to use a nice kind of typical example, I would say. And then once we've analyzed that, also being able to take data back to the field and stake out what I call hot spots or areas that need, whether it's additional shotcrete or maybe we need to excavate more material, whatever it might be. All right, so let me open up my TBC. So what I would like to start with first is looking at how we can go kind of the start of the project and then going into the survey data. So the biggest challenge is always getting that design data prepped before sending it out to the field. So normally what you would do in TBC is you would key in all of that design information from the plan, from the PDF document that you have, and for the alignment, the shapes and all that. What we tried to do with TBC is reduce the time that it takes for you to get that data into a Trimble tunnel format. And so we've got a new tool that I'd like to show here. Let me open up TBC. All right, so I've got a blank project. Nothing at all. There's no smoke and mirrors here. This is simply a blank TBC project. But what I've got, and I'll show you here in my file explorer, is I've got a CAD alignment file. So this has come from the engineer or whoever it might be. It's just a simple DXF. So I'm going to import that tunnel alignment. And you'll see that pops into TBC, and I have that nice 3D line string defining the alignment. So don't need to key in the alignment. I don't have to enter in the geometry. I just imported it in. All good to go. So there's that nice alignment. Now the next thing that we need is the shape, the profile of the tunnel itself. So in this example, I've got a bunch of different types of typical cross sections. We're just going to use one for time's sake, but I'll go into using an excavation type. So I'm going to import that. Again, this is just a simple CAD drawing from the engineering team. So if I zoom into that, it imported kind of at the 0, location. So pretty standard excavation shape, I would say. Maybe a TBM tunnel based on the circular profile. So what I want to do is get that into a design, Trimble tunnel design, so I can stake out and do all the stuff in Trimble Access in the field. So in the tunnels tab of TBC, when you're talking about data prep and getting that information together, I always talk about going from left to right. So you start on the left-hand side of the ribbon and work to the right. So we always start with the alignment. So if you're very familiar with the corridor functionality in TBC, it's very similar with tunnels as well. So you start with the alignment. I'm going to use an existing line, so that line string, or that design alignment that I imported, and I'm going to press OK, and that's going to automatically create a alignment for me, and it's going to have all that geometry populated. You can see that here, and also I can see all the vertical alignment information as well. So boom, we've got an alignment. Step one. Next, we're going to go through the tunnel design process. So first we create the tunnel corridor, and I like to think of the tunnel corridor as like the bucket that holds all of the tunnel design information. So whether it's one design or 4 tunnel designs, that is all held in the corridor. Once we've got the corridor, then we start defining our tunnel design. So I'm going to call this tunnel design 1. And we next define the templates. So the templates hold all of the shape information. So if I have a shape for the shotcrete, for the excavation, for the lining, I would have all those shapes inside of one template. So kind of the container for the profiles. So we'll call this template 1, and we'll just say it starts at station 0. Press OK. And now this is where typically it would take a lot of time for somebody building a new tunnel in TBC. You would have to key in manually key in all the geometry for that shape. Now what we've done in TBC instead is introduce this create shape from CAD command. So instead of having to manually key in that data, we'll run this command, and I'll zoom back to that tunnel design that I imported, and I'll just key in all the information I need. So I'll call this excavation line, and I'm going to apply it to that tunnel in template. And then I choose the line or lines that define that shape. The base location is important. This is essentially where that shape is going to sit on the alignment. So in this case, I'm just going to put 0, 0, and you'll see that that's kind of the point where the alignment's going to sit right here. The scale is really interesting, not particular for this example, but for others. Let's say I've imported from a vector PDF and everything's scaled, so it's not at real world scale. I can apply the scale factor here, and it'll automatically scale that to the real world dimensions that I need. In this case, just looking at TBC, you can see it's already pretty much at real world dimensions, so we'll just leave it at 1. And then when I hit OK, what it's going to do is automatically create that shape and all that geometry. And now we've got essentially, if I make that bigger, we've got that tunnel design already keyed in, and it's defined all of that geometry automatically. So really, I could export that file to Trimble Access and start staking out or as-builting right now. We're done. So kind of in less than 5 minutes, we've prepped a tunnel design in TBC. Now what I'm going to jump to is more after we've collected the survey data. So let me open up my other TBC project. So this is a kind of what I would call maybe a classic or simple example of doing the iterative process of collecting data throughout a NATM tunnel, where we've got 2 scans here. If I zoom in, I've got a scan. Maybe it's easy if I turn off one. I've got this purple point cloud, which is the excavation of this section of the tunnel. And primarily on this side here of the tunnel, what we've done is gone in and scanned it again here with this blue point cloud once a layer of shotcrete has been applied. So we can kind of see how to do an as-built analysis. So we've got the 2-point clouds, and then what I've done from there is I've simply created the meshes, 3D meshes from that data. So you can see that mesh here, basically a 3D representation of that point cloud data. But along with those meshes, I also have the design shape. So kind of seeing all of that in context. So if I turn on all three, maybe I'll change the color of the shotcrete so it's easier to see. Let's change it to, I don't know, what's a good color? Change it to aquamarine. Now I can see in context kind of there's three different layers, right? I've got a design, I've got an excavation, and I've got a shotcrete, and how those all look in 3D. Now, really where the power is how we can combine this and get some analysis from it, where we've introduced what we call the inspection workflow in TBC. So what that is a comparing meshes together. So if I go into the tunnel tab and I go to the inspection map, this is comparing two different meshes. So it could be two as-built meshes, which is what we're going to do in this case, but it could also be an as-built versus a design. So if I want to see excavation versus design or something like that, I could. So I'll give it a name, like call it shotcrete inspection. We've introduced this little classification tab. This doesn't affect any of the data, but it gives classification to that inspection to kind of remind you in the future, what was this for? Was it for shotcrete versus excavation, whatever it might be? So in this case, I'm going to choose excavation and shotcrete. I can apply a layer to it, and then I choose which meshes I'm going to compare. So the base is kind of what everything is going to be compared to, and then the comparison mesh is what's compared to the base. So it doesn't really matter which one, whether it's excavation or shotcrete that's used, but it will kind of flip the signs in a way, right? Which is positive, which is negative. But let's use the excavation as the base mesh, and we'll compare the shotcrete mesh to that. And then of course I can choose a range of stations, right? If I only want a certain section, let's see, I think this is, yeah. So if I only want certain stations, I can select that here. And then I'm going to apply that, and it's going to do some calculations to compare those two. And what's going to result is it's going to create a 3D representation of that comparison. So it's going to take the shape of the base mesh, but it's going to be colored and have the properties of the comparison between the two meshes. And you'll see that in kind of now that it's been created. So if I close that command, and I'll just turn off those other meshes so we can see that easily. So like I mentioned, it's still a 3D object, and it's compared those two meshes together, and it's colorized it based on the differences between those two. So you can see kind of all that information visually in 3D, and there's some basic properties that go along with it, things like overbreak and underbreak areas and volumes. So if I really care about how much shotcrete was sprayed, I can kind of get that from this data here. Another thing that's very useful is the color table. So if I want to change how this is visualized, right now it's kind of mostly green and some oranges and reds. I can go into the color mapping, and that color mapping will allow me to change that scale of the color any way I want. So this is kind of where we've set it here. It's pretty much kind of an even interval in a way, but I could also create my own and then load and save it out and load it into future projects. So in this example, I've got some that I've created here for this webinar. I've got a 5 color and a 12 color. Let's just try the 5 color, see how it looks to start. So this kind of a basic one shows you those colors. And if I press OK, see that it updates the color of the mesh based on those. Now, where I get into the really fun stuff, we're going to open up the inspection view. Now, this is a new view that we created in TBC, especially for this type of inspection, where we're taking that tunnel shape and we're slicing it and unrolling it, making it flat. So we're getting in the end three things. We're getting a flat plan view of that entire mesh, so we can see kind of all of the deviations across it. We're also going to get a cross-section view, which is going to show at that specific station the differences between the two, and what we call a deviation view, which will show essentially a good check for things like undulation and thickness and smoothness in this between the two surfaces. So starting on the left-hand side, this is that plan view. And you see it's kind of maintained that coloration. Hopefully nobody on this webinar is red-green colorblind. This might be a little bit difficult to see, but the idea here is to see all of those deviations on kind of a 2D flat plane. On the left-hand side, the up and down on the axes is the station, and going on the x-axis is the offset from the alignment, kind of up based on going around the tunnel shape. Now, if we want to see like a specific station along that tunnel, let's say I want to look here, I can click in the view and it's going to update the cross section and the deviation view to show me that information. And of course, like in anything in TBC, I can kind of scroll these views around and I can move them. I can close one of them if I only want to see a certain view. Now, if I go into the cross section view and I zoom in, you'll see four things here. The magenta line is the design, so that was where we should have built the tunnel. The blue line is our excavation mesh, and the red line is our shotcrete, so the compared mesh. And then these labels are showing at that specific location the distance between the 2D distance between those two objects. Now, if I zoom out, you can see there's a ton of labels. It's kind of hard to understand what exactly is going on there. So I might not need that density of labels or even in the meshes themselves. So I can change all that going into the settings in the bottom right. If I open that up, in 1 second, there's a variety of settings here for the tunnel view, whether it's the plan, cross section, deviation views. You can customize this however you want. You can change the colors, you can change the line weights and all that. In this case, what I'm gonna do is change the resolution, which will change how many of those labels we have. And just for simplicity's sake, I'm gonna crank it up to a meter. You probably in real world are probably gonna need more density than that, but just for this example, we'll put it at a meter. You can see that's kind of changed the density and where we're extracting values along the tunnel. And it's also changed the grid of the tunnel itself. So you can kind of manipulate that how you want. If you need high density, you need down to 5 centimeters, you can do that. But if you don't need it, there's also the options to make it less dense. And so you can see that more clearly. Now the last piece is the deviation view, and this is showing the differences between the two meshes, but in a way to look at more on thickness and smoothness. So if I zoom in here, this zero line running left-right is the base mesh. In our case, that was the excavation, and the red line is the shotcrete. So I can see based on this analysis how smooth that shotcrete was applied around the tunnel surface. So that bottom axis going along the X is the same axis here in the plan view. So I can see if it was a really shaky sprayer and we didn't get like the proper smoothness along the whole thing, which you can kind of see there is some undulations in certain sections here, but it'll also give me an idea of the thickness too, right? If I zoom in, I can see here on the left side, that's about 0.1, 0.15 in terms of thickness. All right, so that covers the tunnel inspection view. Now, with any good data in TBC, we need to get that out into a nice report. So we've generated this, or we've created this new command called the inspection report. And essentially, it is taking the same information from the tunnel view, but putting it into a customizable report. So if I go into this command, I choose my inspection map, and then I'm going to run it. And it's going to generate a Microsoft Word document that has the similar information for each station interval, in this case 5 meters. I'm going to get a plan view, cross-section view, and a deviation view. And I'm going to also get statistics on things like the volume between the two meshes, the area, the maximum over and under break. So if there was like a spike somewhere in that specific section, we need to know, and so forth. Oops, here it opened on my other monitor. All right, so we've got kind of a summary page. It's got that information here. I can see that across that whole section of tunnel that we're inspecting, what were the total volumes, the total areas, and so forth. And then if I move down for each station, so in this case, in this case 579, 746, I'll get information on that specific cross section, as well as the underbreak, overbreaks, areas, volumes, and maximums, and of course the deviation view. And what I think is really important about this is you can customize this any way you want. Let's say you don't care about the deviation view. You can remove that totally from the report, give you more real estate to make this cross-section view bigger. Maybe you want this cross-section view all on one page. You can do all that and just change the layout all in Microsoft Word. All right, so that covers kind of the inspection inside of TBC. Now, if you have to, for whatever reason, let's say there's not enough shotcrete, or we need to excavate some more material in the tunnel, what we can also do, let me just exit out of the inspection view, is we can create points based on those tolerances and bring those back to Trimble Access to stake out in the field. So for instance, if I know there's a couple hot spots in this area and I need to give that to the field crew so they can take it back and stake out those points, that's what the create inspection points command is for. So I'll show that now. If I open up that command, basically you feed it a point ID of where you want to start. So I could say, I don't know, point 10,000, whatever you want to call it, 1,000. And the important piece here is the grid interval. So how often do I want a point created? 1 meter is probably okay. You could probably change it 2 or 3 meters, whatever is necessary. And the tolerances is the key part. So this is any points out of these tolerances, or sorry, any areas in the mesh that are out of this tolerance, a point will be created there. So let's say I'm going to only look for things that are drastically out of the tolerance, like 0.5 meter. And then I press apply. And it's going to generate those points. I think my layer is off, so let me turn that on. And I'll just minimize this panel a bit so it's easier to see. Now I can see that it's created those points here on the bottom. Actually, let me turn off the mesh so it's easier to see. So it's created the points, and now I can just export those out, CSV, JXL, whatever your preferred method, to Trimble Access and stake out those hotspot locations. So that covers kind of the inspection workflow and the tools. Now we've got some time, so I think what I'd like to do is just look at the questions here before we move on with the end of the presentation. So let me take a look.
Kind of gets some good feedback coming in from your demo, Riley.
Awesome.
Excellent solution for calculating shotcrete. Can I change just the resolution of the labels and keep the resolution mesh? Was one of them.
So let me. Yes, you can in the settings of TBC. You can do that.
Cool. And then
so
another one came.
Question. Oh, sorry.
Go ahead.
Go ahead, Jeff.
Go ahead. That said, this is impressive. Can I use the point cloud of other scanners to achieve it, like the X7?
Yes. So you can use You can use any survey data. So if it comes from a total station or a CSV, and you can use any scanning data that can be imported into TBC. So X7, TX8, or even if it's coming from an LAS or an E57 file. This is a good one here. Frank asked, the inspection tools are showing cross-section information. Can this be exported to a CAD environment? So with the drafting tools in TBC, you can create cross sections, plan, profile views, whatever you need, and from there you can export those sheets to CAD, so DXF or DWG, and that's kind of my recommended workflow if you're trying to get those out, especially cross sections, if you're trying to get those out as CAD. Stephen asked, can you compare cloud to cloud? And yes, you can. That's exactly what I just did. Those two data sets were both scans, one of the shotcrete, one of the excavation. So short answer is yes. You could also compare cloud to total station, cloud to design, really whatever you need to do.
Good question. Just came in. Oftentimes we lose GNSS connection inside a tunnel. Do inspection scans need to be shot from the exact same location for accurate results?
Hey, Dane, thanks for the question. So this is where I think the real power of the SX12 is because when you scan with the SX12, it will reference to your survey control. So if I set up my instrument and I did a resection to my tunnel control points, that scan is referenced to that control. And so if I do that again, so they spray the shotcrete and I scan again, I do the same thing. I set up to the control and I scan. And so those two scans are in the same coordinate frame. They're referenced essentially to each other. So you don't have to worry about that. In situations where let's say you're using just a standard 3D laser scanner, like the X7 is a good example, there are ways you can get that into in those two scans into the same reference, whether it's through some kind of like target-based registration or a cloud-to-cloud, or sorry, not cloud-to-cloud, georeferencing with known locations.
Thanks, Riley.
All right, there's a couple others that I'm just gonna read here, just to make sure get all the ones that were asked a little bit sooner. So Rocky, hey Rocky, thanks for the question. Can you manually set where the sections are cut? So you can change the interval. I think this answers your question. If not, just let me know. You can change the interval in Trimble Access or TBC on kind of how often you want that to be. So it's 1 meter, half a meter, or wherever. You can also, while you're in the field, define what station you want to measure. So if it's a really specific one down to the centimeter, millimeter, you can define that while you're in the field. Alexis asked a question about sample of the tunnel surface every 20 centimeters. I'm not sure I totally understand the question, so maybe if you can type in some clarification, I'd be happy to look at it more. You can't, so I'll try to randomly answer here. If you've collected scan data and you want to sample it down, there's a variety of tools in TBC to sample that down. I didn't show it, but when you're creating as-built meshes in TBC, may as well pop it open here while I have TBC. This as-built mesh command, which is what generates those as-built meshes, there is an option to sample here in the kind of in the mid-right of the screen, sample a point cloud. So for instance, if I have a really dense scan, but I don't need that high density in my results, maybe I only need 0.3 of a meter, I can sample that before I even create the mesh. So it kind of simplifies the results in a way if needed. Not sure if that answers it, but either way, I'm trying to talk more about tunneling.
I think that's what they were after.
Yeah. A question again about, well, do we always have to ignore the floor to be able to carry out the analyses? I think that's dependent on the application. So you can ignore it if you need to, but you don't have to. You can also include it in the analysis. All right, so feel free, keep them coming in. We're getting to the top of the hour, so Jeff and I will just finish off the presentation content, do our part, and then any more questions that come in, we'll answer them here. So moving back to the slides, whoop, jumped a few too quickly. So what I want to finish this off with is kind of resources, next steps. How do you find more information? On the tunneling side of things, we've got a brand new website that I'm really happy with called tunneling.trimble.com. Everyone, feel free to go on there, check it out. I'd love to hear your feedback too. Maybe we need to add some more stuff to it. We've got a great YouTube channel as well, primarily all about tutorials and how-tos with TBC and Trimble Access. So anything I just showed, you wanna see that again or get a nice tutorial about, there's a video on YouTube. I think we're around 60 videos now on there. We also have demo data. Let's say you're trialing TBC for your first time, and you want to trial it in the context of tunneling. There's a ton of different sample data sets for tunneling, as well as a variety of other applications on the geospatial.trimble.com website. And so let's say your distributor is giving you a demo code of TBC to try out. That's a great place to start for some demo data and kind of getting your hands dirty with TBC. All right, I'll kick it to Jeff to talk more about the TBC side of things.
Cool. So similar to Riley, we have quite a few resources on the TBC side of things. So I wanted to point out, the TBC website, as always, and I have a screenshot of that right below the main title here. You can see we have a ton of product information for everyone to access, as well as some important information around support and downloads within Business Center. We also have a YouTube channel as well with hundreds of videos and multiple playlists, so please check that out and use it for troubleshooting or tutorial aspects. And then as well, we have this sample data site now on the Trimble Geospatial site, so you can find anything from mobile mapping to tunneling and geodetic stuff. I mean, please feel free to check it out. It's free and readily available for you guys to go and download. I also want to quickly talk to the new e-learning site as well, and then also, being able to access all of this information on the support tab within Business Center as well. So if you already have a license, just click the support tab, and throughout that entire ribbon, you have this readily available as well. And the e-learning site is really nice to go on and learn TBC virtually and kind of get some interaction as far as hints on where to click, complete lesson plans, and get certificates all free as well. So please check that out. And then next up, we're going to have a couple power hours planned for March and April. There's going to be 2 power hours. I'll be joined by our applied geospatial expert, Daniel Butvitas, who's always a great host. And what we'll do is we'll talk through a complete survey, field to finish through TBC, where part 1 we'll talk about some pre-planning and analysis of the job site and walk through how the data was gathered with the total station, GPS collection, and X7, and how to geo-reference that in Business Center. And then have a part 2 on that second session where we'll cover all things processing and TBC and create the final deliverables for an ALTA survey. You can see how that's really overlapped nicely with the PDF in the background. So registration and details will be coming out later this week.
Cool. The famous Dan the Man doing his part. I'm excited for that one.
He's great. You want to catch that one?
Yeah. Cool. And yeah, well, Jeff and I have left our email addresses up there. If you want to ping us about TBC or tunneling stuff, definitely feel free to. Open door. We are a couple minutes over time, but I think we'll stay and answer any more questions if people have them. So let me just pop up the question here. I saw there's some positive feedback from a few people saying great work on improving the tunneling module in TBC, and thank you. Really appreciate that. It's really driven by you, people using it. So we'd love to hear more from tunneling folks using TBC or Trimble Axis, or if you're not using it, I'd love to hear your feedback on other things we could improve. Let's see here, some questions.
I think
There's quite a few. Thanks, guys, for all of these. Let me scroll up a bit. I think there's some more towards the start. So Jan Eric,
yeah.
hey, great to hear from you. Got a question about interpolation of the design tunnel surface, and how does it work when you change the shape of the tunnel? And so without getting into the technical details, essentially we perform kind of a warp, what they call warp between the 2 surfaces. So if you, for instance, if you have a bigger shape and you're in 10 meters, you move to a smaller shape of the tunnel, we basically perform an interpolation across that 10-meter section to connect those 2 tunnels together. Now, depending on how complicated or how simple you need that to be, it's up to you and how you put those shapes in. So I've seen extremely complex designs in TBC that maybe I'll share in the next time I'm on a power hour, where the shape changes every few meters, and it requires kind of that interpolation to make sure that the surveyors can stake out those changes accurately. Or it could be as simple as just changing from kind of a larger shape to a smaller, or vice versa. So Bruce asked a question more about the SX12 and just kind of elaborating on the scanning capabilities. So if anyone was familiar with the SX10, the scanning capabilities are the same. I believe it's 26,600 points per second. Don't quote me on that. Something roughly around that number. And yeah, so the scanning capabilities are very, very much the same with the SX12. I think what we've done to really leverage those capabilities is improve the workflows in Trimble Access and in TBC. What I didn't cover here, which will be covered in the upcoming SX12 webinar, which I believe is next week, so sign up for that, is the new tools in Trimble Access for doing surface to scan inspection. So being able to use that scan data in the field for more kind of construction verification and so forth. All right, maybe one or two more questions and then we'll end it off here.
One question at the very top, will we always have to ignore the floor to be able to carry out the analysis?
Short answer is no, you can use the floor or you can choose not to. It's up to you.
Yeah, it's the checkbox, Alexis, in the classification.
All right. Thanks, Quentin, for the positive feedback about the classification tools. Really appreciate it. I think that's about it. There's probably a few I missed, and I apologize in looking through all of these questions that I may have missed some. So if I didn't get your question, feel free, please send me an email, and I'm more than happy to talk about tunneling with you. But I think it's a good time for us to end the webinar. Thanks everyone who attended. And for you or for your colleagues, this is going to be available. The recording will be available on demand. You should receive the follow-up link here today or tomorrow with that recording.
Yep. Thank you for hosting, Riley. This is really nice to have you.
Always love doing TBC Power Hours.
Thanks everybody for joining.
All right, take care, everyone.